Right, so question number 3. So this was the first question that is asked in the syllabus, that is reformed syllabus, where an electrochemistry question is asked in the structured essay part. Okay, so this was the turning point of the exams, because nowadays they relate little bit of electrochemistry and thermodynamics into the structured essay as well. Because earlier in the olden stuff, so they has little bit more organic nature, question number 3, and then it changed a little bit about to some inorganic concepts plus organic, and then it changed to like this way. So you have a little bit of thermodynamic stuff or gases as well, right? So this is one of the papers that is they have touched the electrochemistry part as well. So you have given chlorine gas is used as an oxidizing agent to oxidize the metal M2 to M3 plus, right? And the following data are given. So you have given some data, right? So you have given the standard enthalpy change at 25 degrees Celsius, where M solid forms its first oxidation state. M solid is converted directly to M2 plus, and M solid is converted directly to M3 plus. Okay, so all these values are given, and they also given like formation of chloride, which is the electron affinity basically, where we add electrons to the Cl2, which forms minus 334 kilojoule per mole is released, right? And they are also giving the electrochemical cell that is formed between M2 plus and M3 plus and Cl2 and Cl minus. Okay, now don't confuse these three reactions that they have given, or even the fourth reaction that they have given, with this electrochemical data, right? Because there is no connection between these two, because there will be a connection anyhow, but here when you compare about these two, there is no connection, right? Because these data are related to thermodynamics, this data is related to electrochemistry. At one point these two will be connected, but for the moment we don't need to consider about that, right? So the idea is above oxidation is carried out electrochemically. So they are using an electrochemical cell. So write half reactions for this oxidation and reduction process and derive the cell reaction. So you can clearly see this is one of the electrodes that they have given, and this is the other electrode they have given. Now, how do you identify the anode and the cathode? Oxidation reaction at the anode, reduction reaction at the cathode. So how do you identify that? So if you can remember about our typical electrochemistry, I told you the elements or the compounds at the top of the table in the electrochemical series, they are more like to get oxidized, and their reduction potential is lower or negative in nature. So when you think about this plus 0.77 and plus 1.36, you need to understand plus 0.77 is lower than 1.36, right? For an example, 0.77 is on top plus 1.36 is on bottom, according to our electrochemical series. So since this is appearing on top, which means it more like to be oxidized, right? So typically in this electrode, the oxidation should happen. So this is what the cell looks like. So here, these are two aqueous cations that is going to react. So typically our oxidation reaction is M2 plus forming M3 plus and one electrode. So I will stop sharing the screen and I will use the board to explain all this. right? So the idea is this. So you have given E M3 plus M2 plus. Why this is given M3 plus M2 plus? Because this is the reduction potential that they have given. M3 plus M2 plus, right? So this is given as 0.76 maybe. Yeah, I have to check that. 0.77 and the other one is 1.36. It is Cl2 Cl minus because of the reduction, right? Now if you think about now you know this should be anode, this should be cathode, right? So you need to draw a electrochemical cell. So what I'm going to do is first I will draw the Cl2 electrode. So if you can remember, Cl2 Cl minus is a gas electrode. So you need to pump Cl2 gas here at 180 m pressure and 25 degrees Celsius. Okay. So this will be like this, and there will be a platinum plate, and this will be immersed in a Cl minus aqueous solution 1.00 m at 25 degrees Celsius. And now this should be connected to either you can write a voltmeter or potentiostat or potentiometer. And now this should be connected to this cell. So you need to understand in electrodes, typically we describe several types of electrode. Metal electrode, gas electrode, and redox electrode. If you don't know these three, metal electrode, gas electrode, and redox electrode, right? If you don't know those three things, please go through my video. Again, I have to tell you, this is not promotion. Just go through and watch and take the knowledge. That is it, right? So because I have explained everything in my electrochemistry tutorial as well. So this is a type of a redox electrode, which means you don't have like sodium or zinc or metals, because these two, you can see these two are ions. So in a solution where you should have M2 plus and M3 plus at their relevant concentration, right? Then how to connect this electrode? Then you need to use a platinum, because platinum is inert. It just what it does, connect the circuit. So still circuit is not completed. You have to use a salt bridge. So your cell is going to look like this, and this will be your anode, this will be your cathode based on the values. So your anodic reaction will be M2 plus AQ, states are very important, giving M3 plus AQ plus electron. This is your anodic reaction. And your cathodic reaction will be the reduction. So reduction, what is reduction? Cl2 plus 2 electrons giving 2 Cl minus. So this should be gas, this should be aqueous. Then what is the cell reaction? So before writing down the cell reaction, first you have to balance these two reactions, because when one compound is oxidized, the other compound should reduce using those electrons. So here M2 plus is oxidized, removing 1 electron, but for the reduction of 1 mole of chlorine, you need 2 electrons. So which means here you should multiply this by 2. And your overall cell reaction will be 2M2 plus aqueous plus Cl2 gas, giving 2M3 plus aqueous 2 Cl minus aqueous. So this is your overall cell reaction. So all these things you should know. Okay. So typically this is what they have asked, right? So I will again share the screen. oxidation half reaction is M2 plus going to M3 plus. Reduction is Cl2 going to Cl minus. Why I decided this as oxidation and reduction? Because based on the potential values. And cell reaction you can write after balancing. And the next thing is the following diagram. So this is the expected electrochemical cell which I have already drawn. So when you read this thing, automatically you should be able to draw this one. But the idea is they have given the drawn diagram and they are asking what are these. So A, you can automatically, you should understand, okay, now this is the chlorine electrode and this is the redox electrode. So this should be Cl2 gas at 1 atm and 25 degrees Celsius. B is the salt bridge. And C is the voltmeter or potentiometer or potentiostat. D is Cl minus aqueous concentration 1m and E is N2 plus N3 plus aqueous concentration 1m. So all these are already I have drawn here. Okay. So calculate E cell for the above cell. So you can use the typical equation where E cell is equal to E cathode minus E anode, right? So it is typically E anode. So E cathode means the reduction half cell. So we know reduction half cell is chlorine. So its value is 1.36. So this should be 1.36 volts. You need to put units, volts, minus, typically there will be a minus value, but don't worry, here it is still plus, so it will be minus, just you don't need to put the bracket because it is also a positive value. So it will be minus 0.77 when it becomes negative. So you can subtract this and you can write down the value. Okay. Then it starts to ask something related to thermodynamics. So up to here in this question, you can see they are asked about electrochemistry, right? Now they are telling calculate the standard enthalpy change for the cell reaction given in part 1. Okay. So we will again discuss this through the board, right? I will stop in the sharing. And here, I will erase all of these. So what is our cell reaction? So our cell reaction is M2 plus AQ plus Cl2 gas forming M3 plus AQ. So this is 2 plus 2Cl minus AQ. Okay. So how do you get the enthalpy change? That is our idea. And for this purpose, they have given the enthalpic data that we necessarily need. So idea of this one is how you are connecting those data to this reaction, right? So according to this one, the data that they have given is M solid to M plus. I'm not going to put the physical state for the rest. So this is minus 32.5 kilojoule per mole at 25 degrees Celsius. And they are also using M to M2 plus. I will put the states minus 48.5. Minus 82.5 and Cl2 gas 2 electrons 2 Cl minus AQ minus 3340. So these are the typical values that they have given. I hope you can see all. Okay, so right. Now, the idea is how to, if you know the enthalpy, so enthalpy will be typically delta H will be of the reaction, let's say, the enthalpy change of the product minus enthalpy change of the reactant, right? So the idea is how you are going to take the enthalpy change of the products. You need to know the enthalpy change of Cl minus, and you need to know the enthalpy change of M3 plus, right? Which means the formation, right? Enthalpy change of formation of Cl minus and enthalpy change of formation of M3 plus. So we will see whether they have given it or not. So according to this data, they have given the oxidation of M plus, oxidation of M2 plus, oxidation of M3 plus. But here in this cell reaction, you don't see M plus, right? So which means we are not going to use this one. We don't need this one. Because in the reaction, you only see M2 plus and M3 plus, which is this and which is this. And these two are formed from M solid. And this is formed from Cl2, which gives me the idea when you react this M solid with Cl2 to form this and this, how you are going to write. That is the idea. So typically, by using these three data, you need to find the enthalpy of formation of M3 plus, and this one you need to subtract from this and find the enthalpy of the reaction. So how do you find this one? It is formed from Cl2. And how do you form from M3 plus? It is formed from M solid given. How do you find Cl2? It will be 0 because that is the natural state. Natural state means standard natural state is Cl2 gas, which is 0. Its enthalpy of formation is 0 because it is naturally available. And M2 plus, it is also given, right? So typically, you can consider about this reaction, the reduction. That is what the reduction also. And it is minus 334. Okay, which is already given in the equation. So this will be minus 334. And this will be 2 times minus 82.5. Why it is 2 times? Because here it has given only for 1 M3 plus. But here you have 2. And here this will be 0 in the reactant side. And here it will be M solid to M2 plus minus 48.5 times 2. So you know the enthalpy of this. So you can add these two and subtract from this to find the enthalpy of the reaction. Okay, that is one way. The other way is you can see these two form from M solid and Cl2. So you can create an enthalpy cycle like this. You can write here M solid plus Cl2 gas. Okay, and you can put together. And you need to form this one from here and this one from here, which means it gives the idea that the arrow should be like this and like this, right? So from here to here means from M solid to M2 plus, which means this, which gives typically 48.5 times 2, because here there are two metals. Here it is only given for 1. And here also 2M2 to 2M3 plus, which gives me the idea minus 82.5 into 3. Sorry, 2. Because here it is only given for 1 element. And Cl to Cl is 0. Cl to Cl minus, what is the value? Minus 334. Here I don't need to multiply it by 2 because here Cl2 to Cl minus is what they have given. Okay. Now this is a thermochemical cycle. Then you can use the right hand arrow according to Hess's law. Right hand arrows are equal to left hand. So typically delta H theta of the reaction plus minus 48.5 into 2 should be equal to minus 82.5 into 2 plus minus 334. And remember, all these values you should write with units. Units are necessary, otherwise it will be a big problem for you to get the complete answers. Okay, so units are necessary. So did you get that explanation? So did you get that? Okay, so that's good. So what about others? Okay, so typically you will have the oxidation here, reduction and overall cell reaction that we discussed, and the picture and the E cell and delta H. So delta H, to calculate delta H, you can use the direct method, like the formation of these two minus formation of this one, the reactants, or you can use this thermochemical cycle. Even you can use an enthalpy diagram, okay, like drawing this energy levels. Anyway, it's your wish. The idea is you need to get the final answer, right? If the thermodynamic cycle is not shown, but the calculation in equation is shown, it is correct. But award 18 plus 3 marks. Okay, so you can use any method. The idea is your answer should be complete, right? Okay, now this becomes the additional part in that particular year, which we normally don't discuss in our syllabus. So I have given this, I have told this reaction before. If you can remember, I told you in one of the papers, this is already asked. And this is where it comes, right? So this delta G, Gibbs free energy, is connected to E cell, right? If you remember, I think it was Halima who asked me, if E cell is positive, is it means the reaction is spontaneous? If I am correct, is it you? Because in one of the questions we discussed, I told you when the E cell is positive, the reaction is spontaneous. And you ask me, right, why? So I told you, like, it is positive because of this particular reaction. I think she is not here at the moment. I don't know why. What is the problem? So the idea comes from here. I will share the screen. So this is the idea. Okay, if your E cell is positive, which means when you multiply it by this particular equation, delta G becomes negative, which means your reaction is spontaneous. So normally you don't study this equation, right? So these are some additional parts that you should know. Oh, okay, so this is typically university equations that we study in university, but still you need to know this because they have given the equation. You just need to plug because they have given the K value, and you have know the E cell value from this particular equation, and you have to just plug it and find delta G. Okay, then you know delta G. Then finally, if you know delta G, you already know delta H from this question. You have to find entropy. So what is the equation? Delta G is equal to delta H minus T delta S. So that is the normal typical equation for Gibbs free energy. So you know delta G from this question number 5. And when you decide enthalpy from this part 4 of question number 3, no, question, I think it was part A. Yeah, just the part 3. And from part 5, you know delta G, and you can plug this here to find delta S. And important thing is here you see plus 4 plus 1. 4 plus 1, 4 plus 1. Why? 1 is for the answer, 1 is for the unit. So don't forget to put all the units in physical chemistry questions along with it state. Otherwise, you will see you are getting lot of marks that is reducing. Okay. In all many questions you will see if you don't put the units, it will be a problem.